is the British Columbia that's familiar around the world.
And out of any volcano, the top three gases are number one.
Volcanologist Glyn Williams-Jones is warning the crew about the poisonous gases spewing from what's called a fumarole.
Rising from the remote wilderness of British Columbia, not far from Whistler, stands Mount Meager, a volcanic giant that has lain silent long enough to become a mountain of myth and mystery. Its snow-clad peaks belie a restless heart beneath, one that scientists have monitored with mounting concern. Recent reports of dangerous seismic activity have drawn a new wave of research to this enigmatic mountain, whose slumbering power may now be stirring in ways both startling and profound. The warnings echo with increasing urgency. Mount Meager, one of Canada's most closely watched volcanoes, is showing signs of unrest that have piqued the attention of the scientific community. Once regarded as a backdrop to the region's wild beauty, it has now become a case study in geological vigilance, a sentinel whose every tremor could, in theory, presage significant upheaval. Researchers, who have previously predicted a possible eruption before the end of 2025, are intensifying their investigations. What secrets are hidden beneath its ice and rock? What forces, long thought dormant, now threaten to breach the surface? As science peels back the layers of Mount Meager, caution grows. Are these signals a precursor to a singular eruption, or do they hint at a need to rethink our understanding of volcanic dangers and timelines? And what and who stands at risk as the ground beneath this Canadian colossus shifts? Let's descend into the depths of Mount Meager, unveiling the scientific discoveries now fueling intensified observation and global chatter. Mount Meager, a volcanic sentinel in British Columbia. Nestled deep in the rugged terrain of southwestern British Columbia, Mount Meager towers as both a geographical landmark and a simmering geological question. Its volcanic roots reach into the Earth's crust, the remnants of eruptions that once dramatically reshaped the surrounding valleys. Today, attention has shifted from its scenic ridges and glaciers to the tremors now recorded far beneath the mountain's calm facade. Near Whistler, this volcano stands at the intersection of immense forces. The collision of tectonic plates has shaped the region's volatile past, and Mount Meager itself has a history marked by potent eruptions, colossal landslides, and pyroclastic flows. Researchers monitoring its seismic patterns in recent months have noted developments that prompt concern: increased earthquake activity, subtle deformations, and small but measurable rises in ground temperature. These signals become more notable when considered alongside informed predictions of potential eruption within the coming years. What makes these developments concerning is not overwhelming evidence of imminent catastrophe, but rather their unpredictability and the increased frequency of seismic and geothermal activity. Unlike some volcanoes with steady and observable rhythms, Meager's signals have emerged as erratic bursts, quick rumbles, intense but brief swarms of activity, and fluctuations in geomagnetic readings. Scientists, equipped with modern sensors and satellite tools, track these irregularities, searching for patterns that could clarify what lies ahead. Yet, the data paints only a partial portrait of a dynamic and evolving system. Their focus goes beyond cataloging quakes. Researchers are also probing the workings of pressurized magma, gas, and mineral-charged fluids beneath the mountain. Do these signals merely highlight typical geothermal unrest, or are they the opening chapters in a longer-term period of volcanic activity? The definitive answers, it seems, are still buried, possibly within chambers of molten rock beneath the visible surface. An alarming seismic awakening. Recent years have brought a distinctive pattern of seismic activity at Mount Meager. Thanks to improvements in monitoring, Scientists can now detect even minute tremors, and the volcano's seismicity has become more noticeable compared to its long silent norm. Instead of the occasional minor quake expected from a dormant system, Mount Meager's seismic profile now shows sporadic clusters and a generally heightened baseline, a tempo that has observers particularly attentive. Some seismic activity originates deep underground, while other events occur closer to the surface, suggesting complex dynamics in the magmatic and hydrothermal systems. At times, clusters of tremors, termed seismic swarms, have occurred in rapid succession, possibly indicating movement of fluids or magma through fractured rock. While these events are not in themselves proof of an imminent eruption, they do resemble precursors seen at volcanoes that have erupted elsewhere, making them worthy of close study. Ground deformation, small bulges, or changes in the Earth's shape has been observed using satellite and ground-based monitoring. Such deformation can suggest pressurization below the surface. While the changes at Meager have been generally subtle, their occurrence, alongside increased seismic activity, raises flags for volcanologists. However, uncertainty persists. The internal structure and pathways of Mount Meager remain only partially understood. The movement of magma, the behavior of gases, and the complex network of hydrothermal fluids continue to be debated among scientists. What is clear is that the volcano's current pattern of activity differs from its previous decades of quiescence, and ongoing changes must be monitored. As the data accumulates and researchers fine-tune their models, the question becomes whether this is a stage in routine geological evolution or the preface to something much larger. At this point, while the increasing activity is notable and warrants vigilance, experts emphasize that prediction is difficult and that the timeline, nature, and scale of any future eruption remain uncertain. Probing the depths, subterranean secrets, and the magmatic heart. Beneath Mount Meager's icy mantle, a complex network of molten rock and superheated fluids stretches into the Earth. Modern geophysical technologies are helping to gradually reveal this internal landscape. Notably, changes in the local magnetic field have drawn scientific attention. Variations in magnetic readings may hint at the movement of conductive fluids, possibly magma or mineral-rich hot water, within the mountain, though interpreting these subtle signals is challenging. Seismic tomography, using the echoes of earthquakes to render underground structures, has allowed scientists to map some distinctive features at depth. Certain zones appear to be less dense than surrounding rock, possibly indicating intrusions of magma or pockets of hot fluids. Researchers are particularly attentive to areas beneath the summit where activity may be concentrated. Field teams have reported localized changes on the mountain, slightly increased surface temperatures, earlier snowmelt patches, a louder hiss from old steam vents, and an uptick in minor rockfalls or shifting stream beds. These phenomena are consistent with heightened hydrothermal and geothermal stirring, aligning with the seismic and magnetic data. The combination of increased heat, subtle ground deformation, and geophysical anomalies suggests that Mount Meager's magmatic system is active and evolving. Surface gas measurements have also indicated higher concentrations of certain volcanic gases, such as carbon dioxide and sulfur dioxide, both common markers of magma moving closer to the crust. While these findings signal heightened activity, scientists remain careful not to overstate their implications. The data indicate a system in flux, but do not by themselves guarantee that an eruption will occur in the immediate future. The convergence of these signs, however, has intensified monitoring and prompted further research, as similar patterns elsewhere have previously coincided with volcanic unrest. Unraveling Mount Meager's explosive past. Mount Meager's past is key to understanding its present. Geological records and deposits tell the story of multiple explosive eruptions over thousands of years. Layers of ash and pyroclastic debris detail powerful events that have dramatically altered the region's landscape. Mount Meager's last major eruption estimated to have occurred around 2,400 years ago, generated widespread ashfall and destructive lahars, volcanic mudflows that coursed down into river valleys, reshaping the terrain. These ancient events give Mount Meager the dubious distinction of being one of Canada's most hazardous volcanoes. In more recent history, the volcano has also produced catastrophic landslides. Most notably, in 2010, a significant landslide sent millions of cubic meters of debris down Meager's slopes. Although this was not linked to eruptive activity, it underscored the mountain's inherent instability and the persistent hazards posed by weathering rock and ice. Geologists meticulously study layers of volcanic rock and debris to look for correlations between signs of unrest and future eruptions. However, patterns are elusive. Mount Meager's history includes long periods of quiet, punctuated by rare but significant outbursts. This irregularity makes prediction difficult and underlines the importance of constant monitoring. Past evidence therefore reinforces the wisdom of vigilance, but also highlights the complexity and unpredictability of volcanic behavior. The mountain's silent stones contain a record of past cataclysm and may hold clues to potential future events. The broader web, regional connections, and cascading risks. Mount Meager does not exist in geological isolation. The broader region of southwestern British Columbia lies along the edge of the Pacific Ring of Fire, a zone of frequent earthquakes and volcanic activity. Movements of deep geological faults, including those associated with plate tectonics, have long shaped the area's topography and risk profile. Other volcanoes nearby, though mostly dormant, share with Meager a similar setting and potential for unrest. At times, earthquakes or small seismic swarms have been detected across the region, possibly indicating dynamic interactions between underground forces. An eruption, if one were to happen, could cause not just direct volcanic hazards, but could also trigger cascading effects such as landslides or rapid snow and ice melt. These events could threaten river systems that supply water to nearby communities and ecosystems. Downstream flooding, changes in water chemistry, or new blockages could pose serious risks to local fisheries, including important salmon populations. Wider environmental changes add further complexity. Drought has in some years increased stress on local forests, which have also been hit by bark beetle infestations, problems exacerbated by shifts in climate. Loss of forests increases susceptibility to landslides and reduces the natural buffers against erosion. Were a volcanic event to coincide with or follow these climate-driven changes, the landscape could face compounded risks. Scientists are not only studying direct volcanic signals, but also modeling potential interactions with other hazards. The interplay between geological activity, water, forests, and climate is intricate and underscores the need for a multi-layered approach to risk management. Living on the brink, communities, forests, and uncertain futures. For communities in Mount Meager's shadow, the risks posed by the volcano, however remote day to day, cannot be dismissed. Local residents rely on agriculture, forestry, recreation, and tourism, all industries potentially vulnerable to disruption from volcanic activity. Forests that surround Mount Meager, already challenged by drought and pests, would face additional threats from ashfall or changes in water flow following a volcanic event. Heavy deposits of volcanic ash could kill trees, poison soil, and complicate post-eruption recovery. With swathes of woodland already weakened, the effects could be amplified. Community preparedness has therefore become a topic of discussion among residents and authorities alike. Emergency plans are being updated, evacuation drills staged in local schools, and educational materials distributed to raise awareness of volcanic hazards. These efforts aim to bridge the gap between scientific uncertainty and practical readiness should the situation escalate. Still, the unpredictability of Mount Meager's timetable means that local leaders must balance public caution with reassurance. Past eruptions often occurred without prolonged or clear warning periods, and the modern monitoring network, while advanced, is not foolproof. Consequently, residents are encouraged to stay informed and resilient and to participate in readiness activities. Researchers are also in dialogue with indigenous communities, drawing on local knowledge regarding the landscape and historical natural hazards. Blending traditional insights with contemporary science offers new perspectives for managing uncertainty. The evidence of Mount Meager's instability is prompting both anxiety and action. It is changing how people think about the relationship between a wild landscape and human life, and about the balance between the enjoyment of these extraordinary environments and the respect they command. Global reverberation, science, policy, and the search for answers. Mount Meager's activity is now under international scrutiny. Scientists worldwide are sharing seismic and geophysical data, refining monitoring techniques, and using Mount Meager as a case study for improving volcano early warning systems. The increased seismic activity and the hints of magmatic movement are cautionary tales for other volcanoes, especially those in similarly remote or poorly understood locations. This situation also highlights the challenge for policymakers. Predicting volcanic behavior is inherently uncertain, yet authorities must make decisions about investment in monitoring, public communication, infrastructure upgrades, and emergency planning. How much information should be shared with the public, and how soon, given the balance between genuine risk and unnecessary alarm? Environmental researchers, meanwhile, see in Mount Meager's unrest a vivid illustration of how natural systems are interconnected. The volcano's agitation overlaps with ongoing challenges such as drought, wildfire risk, and insect infestations in forests. These factors all contribute to a more fragile and complex landscape. The economic stakes are clear as well. The tourism and recreation sectors could be affected by restrictions or fears of volcanic hazards, while insurance companies and governments re-examine their preparedness for low probability but high-impact events. Mount Meager's signals and the science built around them are shaping not only local but also regional and even international strategies for disaster resilience. Perhaps most significantly, the story of Mount Meager is prompting new collaborations across scientific disciplines and borders. It is a vivid reminder that the lessons of a single, restive volcano can travel far, catalyzing innovations in technology, data interpretation, and risk management for communities around the world. Peering into the abyss, what the future may hold. As the monitoring of Mount Meager continues, questions remain. Are the alarming signals an overture to volcanic activity, or will they fade into a period of quiet? Could the combination of geological, environmental, and human factors trigger a new chapter in the mountain's history? Each tremor, each uptick in gas or temperature brings researchers closer to understanding, but also reveals new complexities. Despite ongoing study, the future of Mount Meager remains uncertain. Advanced technology provides better data than ever before, but the fundamental unpredictability of volcanic systems persists. Scientists can offer likelihoods and models, but must refrain from declaring certainties where none exist. Communities, policymakers, and researchers alike must remain prepared, ready to adapt their understandings and their plans as the facts evolve. Ultimately, Mount Meager is a symbol, not just of the volatility of the earth beneath our feet, but of humanity's ongoing relationship with the forces that shape our planet. The restless heart of the mountain is both a reason for vigilance and a reminder of nature's enduring power and mystery. What do you think lies ahead for Mount Meager and for the communities living within reach of its possible transformations? Is this the beginning of another cycle of change, or simply a marker on the long timeline of the planet's internal rhythms? Stay tuned for more explorations into the mysteries that shape our world. If you want to know what scientists discover next, beneath the ground, across the oceans, or in the forests at the continent's edge, be sure to subscribe and join the journey. What secrets will we uncover together in the restless depths beneath our feet. The story is far from over.